So for the top part of the warm-up here, where it says for 4.4, we're proving triangles are congruent, this top part is kind of like a warm-up, but it's a lot of what we did yesterday, where we start by kind of labeling the parts that we know, and we have to show all 6 pieces of information are true about these triangles. That means 3 angles are congruent to 3 angles, and 3 sides are congruent to 3 sides. That's a lot of stuff to show. Instead, what I want to do is I'm going to come back to this one after we learn our shortcuts, basically, and try to do this using one of our shortcuts instead, and you'll see how it's a much shorter proof. On its own right now, it would be 5 steps, but if I can try to shorten that, again, I don't want to do even 5 steps if I can avoid it, because there's so many givens here to help me get there. I'll kind of use that stuff later. So let me come back to that. I'd rather get more time for like actual proofs so that you get ready for the proofs on the homework as well. So let's go to the bottom here, and it starts off with kind of an investigation, trying to see how we can show these triangles are congruent. So as of yesterday, we know that we can show all 3 angles are congruent to all 3 angles in another triangle, and all 3 sides are congruent to all 3 sides in another triangle. We'd have to show all 6 pieces of information, and that got to be a lot. So here's where we're trying to narrow it down and see how much information do we really need to be able to prove 2 triangles are congruent. So the first thing is saying, what if you only have 1 pair of corresponding parts congruent? That means let's start with 1 angle, and then we'll see the scenario for 1 side. So what we're going to do is draw a triangle and draw 2 triangles that show 1 angle is congruent between the 2. So for example, let me make it a right triangle. Okay, so here's 1 right triangle, because I know that that's a right angle there, 90-degree angle, and I want to create another triangle that also has a right angle, and I'm trying to decide if these 2 triangles would be congruent, right? And there is a possibility that they could be, but if you can draw like a larger triangle like this, or a much smaller triangle that still has the same right angle, the problem here becomes these 2 triangles are not congruent. So we're trying to say here that no, 1 piece of information, specifically 1 angle, is not enough to show that these 2 triangles are congruent to each other, because as you can see, even though they're both 90-degree angles, that's not enough information to show that this is congruent to this. They're clearly not congruent because their side lengths are not the same. Okay, so that doesn't work. We can try a side the same way. If I want to say, and it helps to have a ruler if you want to try this out, kind of like measuring quantities. Let's say I want a side that's 2 centimeters long. Okay, so that's my 1 triangle that's 2 centimeters long. I want to create another 2 centimeter long triangle, or like one of the side lengths is 2 centimeters. But now that I have to pick what the other 2 sides will look like, I could do one like this and make it like a little bit smaller looking, or I could make one like I don't know, like that and this, right? Where I don't know what the angles are, I don't know what the other 2 side lengths are. They don't have to be the same as these other ones, and so again, with 1 piece of information, that is not going to work. These 2 triangles will not be congruent to each other. So we can't just do 1. Let's see if 2 works. 2 angles or 2 sides, or an angle on a side. Okay, so then that's like this last bottom column here, or the row. I'll start with doing 2 angles, 2 sides, and a side and an angle. It doesn't matter which order we do those in, but let's see what happens in each of those scenarios. So for 2 angles, we're going to start with, I'm going to again use a 90-degree angle just because it's easy to work with. So here's my right triangle again, but this time I'm going to fill in 1 more angle. Let's say that that's a 30-degree angle. Now technically we also know then that the 3rd angle is 60 degrees because we can easily figure it out, and we know the triangle sum theorem, or the corollary even, helps us figure that out. But again, because it says A and A, I'm only going to fill in the 2 for now. And so then we have to decide if we were to draw another triangle where they both have, again, a 30-degree angle and a 90-degree angle, does it have to be the exact same size as this one, or could it be bigger or smaller? And that's going to be, you could make it a different size, right? If this stays 90 and this stays 30 degrees, that the side lengths are not dependent on that. That would definitely make different size right triangles. And so, again, these would not be congruent to each other. So we haven't found anything yet. We know that 6 pieces works, but so far 1 doesn't, and we're getting, trying to see if any of these will work for the other scenarios. So then we check sides. And again, I can use my ruler and pick like different measurements here. So let's do like a 1 centimeter side. I'll do this is 1 centimeters, and I'll make the same thing over here, but maybe make it straight, just so that you can see that it doesn't have to be the same orientation. Then I can do another 2 centimeter side, or maybe like that, so it fits nicely. There we go. And then that means my third side is already kind of like decided here to connect those, right? That could be one way I could draw this triangle that has 2 sides. Same thing here, though. I need to make this 2 centimeters. So let's do that. And maybe I'll make it straight up. Like this. So it still measures 2 centimeters. It's still technically the same size as this one. But now when I do my third side and connect these, that comes out to about 2.5, whereas this one was only 1.5. Okay? So you can see that the third sides of these triangles are not the same, right? So this is going to also be no, these are different triangles. And finally, we would try to do a side and an angle. So again, I like to stick to my right angles, but this time we'll also know about a side that's congruent for them. So let's do like either a 1 inch or 1 centimeter or 2 centimeters, it's up to you. I'll just do 2. And then I can do another one that's 2. I can even make it horizontal still, and you can see how that's not going to work. So for this one here, if I want to make a right angle, like this. I don't know what the other 2 sides are, I just know that there's a right angle there, right? Then when I create this new triangle, again, I get to pick what my side lengths are, so I can make it go like way up here, and then like this, still a right angle, but clearly those are different sizes, right? And so as soon as you get to the different sizes, then nope, they're not congruent. Can't make them congruent because the sides are different. So that's why we're not really getting anywhere yet. I'm going to write down at the bottom here that not 1 or 2 pairs of corresponding parts works. As in, like, what I mean by works is even though I showed 1 or 2 pairs of corresponding parts are congruent to each other, they were not showing that the triangles themselves are congruent. So that means that anytime you're proving triangles are congruent, you can't just show 1 piece of info. You can't just show 2. We have to look into 3. Maybe we'll get lucky with 3 pieces, like that's where it kind of gets to these new postulates and theorems, where when we show 3 sides or 3, whether it's angles or sides, let's see what happens. Okay, so we're going to go to the next page, and these are already filled in for us because they all work, or almost all of them. This one at the bottom does not work, and if you notice, there's no, or actually in this one here on the top right also didn't work. So you have to read them carefully. Let's go through, and I'm going to highlight the ones that do work. They are on your yellow sheet as well, and that's what we're going to use as we prove things. Okay, so the first one that does work, this is 3 pairs of information, 3 pieces. So it's a side is congruent to one side, then the second side is congruent to another side, and then finally the third side of the triangle is congruent to the third side. So it says if 3 sides of a triangle are congruent to 3 sides of another triangle, then the triangles have to be congruent. Now you might wonder, like, what about those angles? But again, it has to do with how you're creating it. If I take my ruler and I decide to make it, I don't know how long this looks like it's a little over 1 inch, and then I have to make sure that one's a little over 1 inch as well. There's no other way to draw those 2 triangles. They will be the same exact shape and the same size, and that's why they will be congruent. So this definitely works. And again, SSS stands for side, side, side. And then there's a little congruent symbol after it. So on a proof, you can literally just say SSS congruence. Whenever you've shown that 3 sides are congruent to each other, then you can use this to say, yep, my triangles are congruent. All right, here's the one that doesn't work. for AAA. If you notice on the front page, we did AA, and I said at the time we could easily figure out what our third angle is, and it still won't be congruent. That's why this doesn't work, because even though all three of these angles are congruent to each other, notice the size of these triangles are different, right? So that's not going to be enough information to prove the triangle's congruent. So please never use AAA. I'm going to write it right here. Do not use this in a proof, because it's not actually a theorem or postulate. It's also not on your yellow sheet. If you look at what's on the yellow sheet, there's only so far, starting with SSS, and then we go through to the rest. So we're on the first one right now, which says SSS, congruence, and then let's get to the rest of these. So ASA, it's kind of like as you read the letters, give yourself, like, spell it out and say angle, side, angle. It has to be in that same order. So where the side is kind of like in between the two angles. So it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So look carefully at this diagram. These are the two angles that we knew were congruent to each other. For the side that has to be congruent, it has to be the one in between the angles, not the other two sides. Okay, because if it's one of the other two sides, it's a different theorem. We're about to get to that one. But right now, when we're working with included side, it's the side that's in between the two angles. It's got to touch the angles themselves. Okay, if that side was not touching those angles, then we're going to get to the next scenario. Okay, so this is called ASA, angle, side, angle. Also works, so I'm going to highlight that. And it also is on your yellow sheet, and you use that on proofs as they come up. Okay, here's the next one. If two angles and the non-included side, this time the side can be on either of those other ones, as long as it's not the one that's in between the two angles. So this is non-included, and then it has to be congruent to, again, another triangle with two angles and a non-included side of the other triangle. Then the triangles would be congruent. This is called AAS, or angle side. And that still works on a proof as well. The last one that works is called side angle side, SAS, and that's when you have two sides and only one angle, but the angle has to be in between the two sides. So the angle, both sides will be touching that angle. If they're not, then you cannot. There's no such thing. We're about to get the last one, which is not a possibility. Okay, so this one works. Again, look carefully at what it's saying. It has to be the included angle of one triangle with the two sides, and then same thing for the other triangle. And finally, the last one is called SSA. Again, this one does not work, and I'll show you why in the picture. But first, let me write down, do not use this in a proof, or as any reason ever, even if it's not a proof and you're doing, like there's going to be questions where they give you a diagram of a triangle and it'll say, which theorem or postulate would you use? SSS or, SAS, ASA, one of the ones we've highlighted. You don't want to use this one because it's not an actual theorem or postulate, and here's why. It says if two sides and a non-included angle are congruent to two sides and a non-included angle, then there's not enough information to prove the triangles are congruent. Here's why. Looking at the diagrams, and I'm sorry it didn't print so great, it's showing us that these are the sides that are congruent. So this side is congruent to this side is congruent to this one, and we have this angle is the same, like maybe they're both like 30-degree angles, but notice that these two triangles are different sizes because that third side could technically be longer whenever this works. So like this makes it so that they're not congruent and there's no theorem here. One way to help you remember this is if you turn those letters backwards, it makes a bad word. So it makes it easy to not do that, especially if you're writing it that way. If you catch yourself doing that, stop and know that it is not going to work. This is not going to work in a proof. All right, any questions on that? Okay, so like I said, we're going to go back and try the proof that was on the front. And actually, yep. And then the bottom part here, though, just so that we can practice one together, we'll do one of these together as like kind of getting ready for a proof. and then we'll do one proof together on the front page. The homework tonight does have, again, like I said, 3 proofs. I'd highly recommend doing those proofs in class today first, maybe, so that you can get that extra help while we still have lots of time. And then you can always finish the rest of the homework up, because there's not much more than just these 3 problems for the practice. Okay, so it says determine whether or not you're given enough information to prove the triangles are congruent. If you are, then you're going to identify the theorem or the postulate that you could use to prove the triangles are congruent. Okay, so let's start with labeling, marking up this diagram. I highly recommend doing that whenever you do a proof. So we have AB is congruent to ED. So we just mark that with the little tick mark. And we have some parallel lines here. AB, line AB, or segment AB, is parallel to segment ED. Okay, so not only is it congruent, it's also parallel, which means I'm going to get some type of angles here, potentially alternate interior, alternate exterior, corresponding, whatever they are, we'll hopefully find. And we're trying to get enough information. Remember, we need 3 pieces of info to be able to prove these triangles congruent, because that's what we just found. It's one of these ones that we highlighted. Okay, so we have 4 possibilities. First thing I do is I say, okay, I have one side. That's great. You're getting somewhere so far. And then we need to have either 2 more sides or 2 more angles to be able to work with, getting more information. Or I could have an angle. Actually, yeah, that's all I can do. I can either do 2 sides and an angle, 3 sides altogether, or 2 angles and this one side that I already know. So if I can just get 2 more angles, I'll be gold. Then I can go ahead and finish that proof up. And there's actually more than one way to kind of go through this. Some people might say, well, I noticed the vertical angles there. Can I use those? Sure, you could. If you want to mark them as your, part of your angles, you could absolutely do that. I would recommend marking either in a different color or use highlighter or something, because you don't want to get confused about what you already knew and where you're going. Okay, so I already know these 2 pieces because of the given, but everything else that I want to show in my proof, I'm going to use it by red pen. Okay, so I could either do the vertical angles, but I see already that these lines are parallel. I could use alternate interior angles first. Right, so remember, only one transversal when you're working with parallel lines. So my alternate interior angles could be this one and this one. Those are alternate interior because they're in between the parallel lines on opposite sides of this transversal. I could also do the other pair of alternate interior angles if I look at this transversal this time, and it's on opposite sides. But if I do that, I have to use the 2 rings around it. If I did it this way, does anyone see which of these that we highlighted above that this is? Look at it carefully. There are 2 angles and a side, but it's either going to be ASA or AAS. Which one makes sense here? Anybody have an idea? Yeah, Sarah? Yeah, you got it. So it'd be like ASA. You can kind of use your pen or pencil to kind of go through it just like that. So this is going to be ASA congruence. But we had to, so first of all, this is a yes, because it said, could it be proven congruent? Yes, they could. Specifically by ASA, and we used the fact that we had alternate interior angles. So I'll put that in parentheses. Now let's say instead, and I'm going to do this on a separate scrap sheet, let's say instead that you wanted to use the vertical angles instead. Okay, so here's my same diagram that's there, something like this. You still start off with just knowing that these are parallel and congruent. And let's say you start with saying, I want the vertical angles to be congruent. Sure. Then you have to look at it and say, well, I still need one more piece of info because I only have an angle on a side. So then you still would have to mention the alternate interior angles, but you could choose to mention only one pair. So for example, like that. Now, looking at this diagram, which triangle congruence would work? It's not ASA anymore. Yeah. It's perfect. Yep, AAS, because the side is not in between the 2 angles anymore. So this could be a different proof for somebody. They would both be correct. If someone chose to do alternate interior angles and then ASA and didn't bring up vertical angles at all, you would be able to do that in 3 steps, right? Pretty short. You would say, given, you'd say if lines parallel, then alternate interior angles, and you would write down both pairs. And then you could do ASA congruence and be done in 3 steps. If you did it this way, it would take you maybe just 4 steps instead, because you would say vertical angles are congruent, and then alternate interior angles, and then finally get to AAS, right after the given. So both are absolutely fine. It's okay if it would take you 3 or 4 steps or even more, and they're just different ways of doing it. Okay, so that's all for kind of, you can try out more of those if you want to, but I'm going to, again, go back to the front. This proof, again, was initially intended to show all 6 pieces, and so because of that, it gives us a lot of givens. So we're not going to use all of those givens, but let's start by marking up the diagram and then see where to go from there. But again, I'm going to try to use, like I'm coming back to this, so I'm trying to use one of the 4 triangle congruences, so either SSS, SAS, what was the other one? ASA or AAS. Those are the only 4 that we know so far. I want to try to pick one of those to once I've labeled enough here. So it's still the same diagram actually. So the vertical angles could still come in handy, but let's see what we're at. So C is the midpoint of BD. I can't really label the diagram with this just yet. I'm going to do that in the red pen because eventually I'm going to use the definition of midpoint to show the tick marks, to show that these segments are actually congruent to each other. The next piece I have though is that AB is congruent to ED. And I even have parallel lines here again, AB and ED. So if I wanted to do this proof the same way that I did the other one with ASA or AAS, I could do that using the alternate interior angles or the vertical angles with the side and be done. That's one option. Or if I want to practice using the definition of this, because we haven't done that yet, I'm going to try using this idea for this next one. But there are literally so many proofs that you could do because there's so many givens included in this problem. Okay, so the one way is, again, what we did on this, like what we were talking about here, that would be one way to go through this with vertical angles and alternate interior angles. And then to get to AAS, same diagram again, same piece of information, but even more, because the other piece of information was just these. Now I have this extra piece here. So now I'm going to try to use this piece. The C is the midpoint of BD and AE to kind of go on. Okay, so because of that, I know that these are going to be congruent. Okay, so now which triangle congruence does it look like? Of these 4. SSS, yep, perfect. So this is the one that I want to use, but remember we already said if you want to do this one instead, you could absolutely do that and you get done in 4 steps. If you wanted to do the one that we just wrote down on the last page, you could do ASA and do it in 3 steps. I'm going to do it in even same thing in 3 steps here using the definition of a midpoint. Okay, so this is the one on your yellow sheet. If you don't know how to write it, it says if midpoint, then divide segment into 2 congruent segments, and we're going to write down what those segments are for step 2. It's going to be, here's where the order matters. We've got to be careful with how you're writing the letters now. I know it feels like it's not a big deal and you should just like write BC and CD or whatever it is, but here's where you want to look at the triangles to help you write the order. You get to pick the first one. So like let's say I want to say BC. I have to say what it's congruent to. Look at the triangles. BC is the 2nd and 3rd letter. So then DC is how I need to write the 2nd one. If you wrote CD, I have to mark that wrong. I can't leave it correct on the proof because it's technically not corresponding then. You've changed the order of the letters. Okay, so that's one of the sides, right? The other side is AC. Again, you get to pick how to write the first 2 letters. You could either say AC or CA, but if I chose AC, that's the first letter with the last letter, so this is going to be EC. Don't forget the bars, and then you can always look at the diagram and see that that makes sense, right? The angles and the sides all correspond, and what I like to do on the side here is keep track of what I have. This was one side. Now I just found 2 more sides, and so now if I have SSS, that's my 3rd step. And I can write down the triangles are congruent. So this originally was going to be 6 steps long. I think it was 6 or 5. If I had to show all 6 pieces of information, which I didn't want to do. That's why now that we know this, we can always do these shorter proofs because we have these shortcuts. Again, any of these 4. All right, so I'm going to stop there.